Consider that f of x is a periodic function with t is equals to 2 pi, and f of x is equals to we have a piecewise there, which is x plus pi starts from negative pi to 0, and we have x minus pi, which starts from 0 to pi. Now they say here, draw a graph of f showing one full period. Ne? So what you have to do, first things first, you draw your Cartesian plane there, and then you can see the lowest value you have there is negative pi. So you're just gonna make negative pi there, 0, and your last value is positive pi, which is that one, which is positive pi. You can make just pi there, and you can make a negative pi there. And then now what you're gonna do, you already know that the first value is pi, né? You can just make a dotted line there. Okay, this is where this is all gonna start, né? You know your x value is negative pi. In order for you to know your y value, you must take this and substitute there, and then it's gonna be like this. When you substitute negative pi there, it's gonna be negative pi plus pi, which is equals to 0, meaning that the corresponding y value is 0, meaning that it's that point there, né? Then now you can check this one. This thing here tells you if this point, which is negative pi, is it included or not, né? If it says less than or equals to, that means that that point is included. But if it just says less than, that point is not included, né? So I'm gonna show you that if they say this, né, just know that that point will be a strong dot where it starts, né? But if it's just this, it means that it's gonna have a hole, né? But in this case, it's not gonna be a hole because that negative pi is included, so it's gonna be a strong dot. And we know that this starts from negative pi up to 0. So in order to know the corresponding y value, we must take that one and substitute there. Then we're gonna have 0 plus pi, which is just gonna be pi, meaning that the corresponding y value is pi. That point you can see, oh, it's not included because it's just less than, eh? So you're just gonna make a hole there, and then you can do this, and then that is your first graph of that piecewise though, the upper part, né? Then let's go to the lower part. In the lower part, what you're gonna do first, you're gonna substitute. You know that this happens in this line. This is where x is 0, né? And then now in order to know what is the corresponding y value of that, you have to take this and substitute there, which is going to be 0 minus pi is equals to minus pi. Meaning, this means that this is going to be your corresponding y value to that 0 and x. Fine. And then now you have to know what is the upper part. And from here, you can see that it's included. So it's going to be a strong dot. And then now you have to take this one again, because you know it will take place in this one. This is pi, right? So it's going to take part in this dotted line here. In order to know what is the corresponding y value, you must take this and substitute in the place of x. You're gonna have pi minus pi, which is 0, so meaning it's gonna be that. And then now the best you can do is to do that. Who says is f of x odd, even, or neither, ne? So what you're gonna do, you're gonna see here, okay, you have this one and that one, ne? Now let's start with the first one. let's say our f of x is equals to x plus pi. Ne? So how do we determine if something is even or odd or neither? Like for odd ones, when you substitute negative x in the place of x in f, you are supposed to get minus f of x. Ne? But now if something is even, when you substitute the negative x in the place of x in f, you are supposed to get a positive f of x. Ne? Now here, our f of x is equals to x plus pi, right? Then when we substitute negative x here, you will see that this is going to be negative x plus pi. So our f of minus x is equals to minus x plus pi. Then you can see from this thing has nothing in common with this one or even that one. Ne? So what you can do is that, okay, you can try to take out the negative sign from the right hand side. Then you are going to be left with x minus pi if you do so. Then you can see, oh, there you have x minus pi. Therefore, at least this has something in common there. Then meaning that you can name this thing to be your f. So this thing is f. Therefore, when you substitute minus x in the place of x in f, you get minus f of x, meaning that you have an odd function there. Ne? But now, for more clarity, let's do the second one. Here, the second one, f of x is equals to, the second one is x minus pi. Then now f of minus x is going to be equals to minus x minus pi, which is now what you are getting there is minus x minus pi. Then what you can do there is that take out the negative sign, then you will be left with x plus pi. You can see this x plus pi is the same as that x plus pi, meaning that it's f, right? So it's going to be f of minus x is equals to minus f of x. Therefore, the function, I can just say f is odd. How did you see that? F of minus x is equals to minus f of x. You have proved it using both. It's question 3 says, write down a Fourier series of a partial sum of a Fourier series showing at least 4 terms. So this is how the Fourier series will be. So now, before we can write it into Fourier series, we must be able to determine what is a0, an, and bn, and here are the formulas on how to find those. A0 is equals to 1 over L, integration from negative L to L of f of x, and then now an and also bn as like that. Now let's start with a0. Ne? In order for you to know what you are going to substitute with in the place of L, you know that the period is equals to 2L, and we are given here that the period is 2 pi. Then 2 pi is equals to 2L. You divide by 2 both sides, then you see that your L is going to be pi. Then let's start with A0. A0 is equals to 1 over L integration from. Now there you have two, there we have this one and this one. You're gonna start with the upper one, which is now that is x plus pi. X plus pi dx, and then now you're gonna see there it starts from negative pi up to 0. So it starts from negative pi, it ends at 0. We said L is going to be pi. And then now plus 1 over pi, which is, and the second one starts from 0 to pi. So 0 to pi, and then now it's x minus pi, that one, dx. Then now 1 over pi into the integration of x is going to be x squared over 2 plus integration of pi will simply be pi x. Remember that it starts from negative pi to 0 plus 1 over pi, and this one is going to be x squared over 2 minus pi x, and it starts from 0 to pi. Then 1 over pi into, so you're gonna start by substituting the upper one, which is going to be 0 squared over 2 plus pi times 0 minus into, it's going to be minus pi squared over 2 plus pi times minus pi. Then we are done with the first one. Then you go to the second one. Then you're gonna substitute with pi, where it's gonna give you pi squared over 2 minus pi times pi. Then now substitute the lower one. So when you substitute that one, you can see that it's just gonna give you 0, and then 1 over pi into, so this one is gonna be 0, so this is gonna be negative, that one is going to be pi squared over 2, and then now this negative and that negative will give you positive pi squared, then plus 1 over pi into, this is going to be pi squared over 2 minus pi squared. And then now you can see that these are the same. Then you can simply say minus pi squared over 2 plus pi squared, then plus the second batch, which is pi squared over 2 minus pi squared. Then this and this cancels. Therefore, our a0 is equals to 0, meaning that when we are writing our Fourier, we are not gonna have this part. And then let's go for an. An is equals to 1 over L integration from negative L to L of f of x times cos nx dx. 1 over pi integration, we know that our first function starts from negative pi to 0, and it's of, what is it of? It's of x plus pi, and then cos nx dx plus 1 over pi integration from 0 to pi of x minus pi cos nx dx. Now here, when you are doing this one, you will have to use the u substitution, where this is integration of u dv and this is integration of u dv, and you're gonna use the u substitution in order for you to be able to integrate this. So 1 over pi, let me just write the formula for the u substitution. It's the integration of u dv is equals to uv minus integration of v du. Then here 1 over pi into, and then now here your u for the first one, u is gonna be equals to x plus pi, and then now your du is going to be just gonna be dx, because when you derive that you get 1 dx. Then your dv is going to be cos nx dx, and then your v will be sine nx over n. Then now you follow this formula, is going to be u times v, which is our v is sine nx over n, minus the integration of v du. Then our v is going to be sine nx times, then du is dx over n here. So what you can do, you can take this 1 over n to be outside. Let's start with this one. It starts from negative pi to 0. 1 over pi into, then you do this part, it's going to be x plus pi sine nx over n minus 1 over n times the integration of sine is negative cos nx divided by n, from negative pi to 0. But you will still see that this and this will give you n squared, and this will give you a positive. So basically it's cos nx. Then now you can substitute. Now you start by substituting the upper bound, right? When you substitute here in sine x 0, it's gonna be 0, so this term is just gonna be 0, plus when you substitute 0 in cos, you're gonna get 1, so you're gonna have 1 over n squared. Then minus, when you substitute pi here in sine, it's gonna be 0, which causes everything to be 0. And then now when you substitute negative pi in cos, it's just gonna be cos, let's just say pi n, because over n squared, because cos is a what is that called? Cos is an even function. Even if you put a negative value inside, it's gonna give you a positive number. 1 over pi into 1 over n squared, and then now minus cos pi n over n squared, and then it's 1 over pi into, you have here, you can take out the n squared, then you are left with minus 1 minus cos pi n. And then after that, you know that cos pi n is an identity which is equals to minus 1 to the power of n. So you can simply say 1 minus 1 to the power of n. And you know that if you put odd numbers here, if you put odd numbers like 1, 3, 5, and 7 will just give you minus 1 from here. You can test it. Then it's gonna be 1 minus into minus 1, it's gonna be 1 plus 1, which is gonna be 2. You see, so it's gonna be 2. But if you put even numbers here like 2, 4, 6, and the answer that you're gonna get is gonna be 1 minus 1 to the power even will give you positive, which is gonna be 0, né? So meaning that here we do not want even numbers, but we want odd numbers. So you can just write the number that the odd numbers will yield, which is just 1 over n squared pi into 2, and just state that n is odd for this one. n is odd, therefore our an is equals to 2 over n squared pi. Keeping it note that n is odd. And then now here is the second part. This one is starting from 0 to pi. So an is equals to 1 over pi into, I'm just gonna do this one, x minus pi, and then now, and this is gonna be sine nx over n minus the integration of sine nx over n dx. Then now what you can do, take the 1 over n outside and integrate this part, which is gonna give you cos nx over n, so negative cos nx over n, then this negative, and that will give you a positive as well, and therefore you will have from 0 to pi, you will have 1 over pi into x minus pi sine nx over n, and then now plus 1 over n squared cos nx. And when you substitute there from 0 to pi, you start by pi, but you know that sine in pi is 0, so meaning that the whole thing is gonna be 0 here. And when you substitute pi in cos, you're just gonna get cos pi n over n squared. You know that cos pi n is minus 1 to the power of n plus, minus the lower bound, which is 0. So when you substitute 0 in sine, it's 0. Substitute 0 here, it's gonna be 1, so it's just gonna be 1 over n squared. So therefore it's gonna be 1 over pi into let's take out the n squares, the n squared outside, which is gonna be minus 1 n minus 1. And then here you're gonna see that according to the identity here, when you substitute the even numbers like 2, 4 and 6, it's gonna be 1 minus 1, which is gonna be 0. Therefore we are not gonna use them. When we substitute the odd numbers like 1, 3 and 5 and so on, you're gonna get when you substitute, let's say 1 there, it's gonna minus 1 power 1 minus 1, then you're gonna get minus 2. So it's gonna be minus 2 over pi n squared. And note that n is odd. So what you're gonna do, this is our first an, the first an for the first part and second part. So an is gonna be equals to, now it's gonna be, the first an we got was 2 over pi n squared, and then the second one that we get is minus 2 over pi n squared. Therefore this is 0. Ne? In this one we are going to try to find bn there, and then now we're just gonna go straight because this is integration. So you know integration by parts, this is gonna be my u, and then now my v will be negative cos nx over n, then minus the integration of v du, so which is gonna be equals to positive 1 over n integration of cos nx dx, that will end up being sine nx, and that it will be n squared there. Here this is from negative pi to 0. The second one is going to be x minus x minus pi times, and this is going to be negative cos nx over n, then plus 1 over n squared sine nx. Because these two things are not so much different from one another, they yield the same derivative, so it's just going to be the same thing from 0 to pi. Then you're going to start to substitute now. So when you substitute the upper bound, which is 0 there, you're going to get this is going to be here. When you substitute 0, you're going to have pi. Let's put this minus up front. When you substitute 0 here, you're going to get 1. So it's just going to be negative 1, which is, there is the negative, and here is 1. Plus 1 over here, it's going to be 0 when you substitute 0 there. And then now you're just going to say minus. When you substitute negative pi there, it's going to be negative pi plus pi, then negative cos pi n, because when you substitute pi, negative pi in cos, you just write it positive because cos is an even function, divided by n. And for the first part, when you solve it, 1 over pi into, it's just going to be negative pi over n, and this one is going to be 0, so it will make everything to be 0 when you it multiplies there. So plus 1 over pi for this second part. When you substitute pi there, it's going to be pi minus pi, which is going to be 0 over n, and then now plus, and then now when you substitute 0, let's say minus, because we are substituting the lower bound. When you substitute 0 there, it's just going to be negative pi times minus 1. When you substitute 0 here, you see it's negative, it's going to be minus 1. When you substitute 0 here, you're going to be left with that negative pi. So it's going to be negative pi times negative 1 over n. And then it's going to be plus 1 over pi. You can see that here you're going to get 0 because pi minus pi is 0. So you're going to have this minus times minus here, you get a positive. Positive times a negative, you get a negative. So it's going to be negative pi over n. And you will see that this and that are going to cancel, this and that are going to cancel. It's going to be negative 1 over n, negative 1 over n, which is going to be negative 2 over n. And that is your Bn there. Now, in order for you to be able to find the Fourier series, you see f of x is equals to a0, but we know that we don't have a0. And then now an, we do not have an. Therefore, our Fourier, it will be a sine series. N is equals to 1 infinity bn sine nx. So they said you should write at least 4 terms. So what you're gonna do, you're gonna have this first, substitute your bn first, which is minus 2 over n sine nx. Then now you're gonna go forward and say, okay, we're gonna start from n is equals to 1, 2, 3, and 4. It carries on, but we just need the first 4. So it's gonna be minus 2 over 1 sine 1x plus minus 2 over 2. You see n is changing, sine 2x plus minus 2 over 3 sine 3x plus minus 2 over 4 sine 4x. Then you're gonna say plus going forward. And then now this is gonna be minus 2 sine x minus 1 sine x minus 2 over 3, sorry, sine 2x here, then sine 3x and minus a half sine 4x plus going forward.